Hello guys, today we will learn how to map the changing data in ArcMap, particularly changing the impact of tornado, its movement from point A to point B. So when values are associated with data that change location, you must see it if the values are also changing. If so, the data is changing both in time and magnitude. So in this case, using a line will be not only useful for showing the current track, but also can be applied for making prediction how the data, for instance, in our case, tornado will evolve and where it will be after, for instance, a certain amount of time based on the previous data. So if the line segments between locations are short, it shows also the location is changing slowly. It means that it shows the speed of the change. So let's imagine a scenario. Let's say that one area is impacted by tornado. So through the local weather gathering services, we were able to get the locations of the actual touchdowns of tornado, the tornado's magnitude, usually measured from 1 to 5, where 5 is the strongest magnitude, and the wind speed it moved through the town. So we want to map both the change in location as well as the change in the tornado strength and wind. So here we have this tornado which crossed on April 7 through the city. We can see and go and check here this attribute table. So Fujita, it means the magnitude of tornado. See, 1 is the smallest one, 3 is much larger, 2 is the second largest. Not very strong. And we also have this line segment. We can check here and uncheck tornado pass. So this is a wind speed of certain pass. We can change its polyline. As you can see, wind speed from this direction to this direction. It's in let's say kilometers in per hour. Larger wind speed, even larger. This is the smallest wind speed. So let's go to this tornado map and go to properties. Let's go to symbology tab, and this is our Fujita. We have these different types of symbolizing. Well, we can go to gradiated colors, choose Fujita, see that the symbols changed differently. We can choose either colors or symbols. I support symbol. I choose symbols because see that we want to map the magnitude of the tornado. So it automatically chooses this symbol size, which is a dot, which becomes bigger with a scale. You can change the color. We can also change the symbol size. So let's also we can change the color. For instance, we can make it, for instance, red one. You can both choose different sizes and different colors as well. In this case it will be more interesting, but in my case I decided to choose one color. So see that the magnitude of tornado was smaller here, it becomes bigger over time. And now let's go to this properties of this tornado path, which is a line polygon. We can go again to this gradiated symbols. I want to map this wind speed. I don't need this normalization. You can also check here proportionate symbols, draw quantity using symbol size to show exact values. I don't think that this is appropriate, but we can just check. Oh yes, it's actually kilometers in kilometers, but doesn't matter. But from this map we can see that this area see that it has much larger wind speed. I mean the tornado speed or wind speed. So its wind speed is here. This one is smaller. This one is even smaller. But I prefer to use this gradiated symbols, wind speed. We can change different types of segment symbols. Existing road are all railroads. We can, let's try to no for wind speed, so let's use this one. So from this information we can conclude that tornado magnitude was relatively small here, both one, and it significantly increased here, as well as wind speed also started to increase. So maybe you know that this tornado magnitude also directly correlated with wind speed. Bigger the wind speed, the larger the tornado and its effects. So now we will try to analyze the impact of tornado using buffer tool on these buildings according to the area it passed. So we will use this buffer tool, as you might know from previous videos, buffer analysis. So buffer analysis, we will do buffering for this tornado April. Let's choose this output file. We will do based on the field Fujita. Tornado. We will do for tornado pass buffer distance. So this is a buffer distance values. So this is how this tornado was impacted the surrounding buildings based on this buffer. It's in meters. So it's full, round and planar, and the solve type all. Let's click OK. So this is how tornado impacted the surrounding buildings. You can see this one polygon was created. Let's make it more transparent. Go to properties. Let's make it 50% transparent. Also symbology. Let's choose this one. So we need to know now how many buildings first have been impacted by this tornado pass, and we need to know also the type of building. So we have this building footprints here. So these are the buildings. This is the use code. What kind of buildings? Commercial, residential, multifamily, etc. With floors, with the year built, etc. So this is a building footprint, and we go here, and so we're choosing from this building footprints, right? We're choosing from this layer, using this buffer. We need to choose, this is a buffer area which is damaged the buildings, and we will use this intersect the source layer. Let's this spatial selection method intersect the source layer, buffer tornado from building footprints target layer. Okay, let's click OK. So see that we see these buildings which have been impacted by the tornado. We can go to building footprints, open the attribute table, and go to this show selected records to see what how many. So first it was 2000, more than 2000 buildings have been impacted by tornado, and these are the building object ID, use code, its height, year of the building, etc. For instance, we can summarize the data. We can go to this use code field, click the right button of a mouse, and choose this summarize. So we will use this use code to statistically analyze the what kind of buildings, how many buildings have been impacted by the tornado path. So summarize on the selected records only. Yes, I will summarize on the selected records, so I don't have to export this selected records into a separate shapefile. Do you want to add? Yes, I want to add results as a table. Let's open the table now. So this is a summarization of use code. We can go to this building footprints, open the building footprints to understand what does it mean. So use code, add value, see that each number summarizes certain amount of use code. So we have here this 1 2 3 5. Let's open again. Categories, use code, add. So this the first is 1517 buildings. It's code 1, it's residential buildings. Second is 488, it's number 2, it's multi-family buildings. 30, number 3 is commercial buildings, and 10 buildings, 5 governmental buildings have been impacted. We can summarize other field as well, for instance year built. Let's click again. This is our table. So most of the buildings, let's sort ascending. No, let's sort ascending according to year built. So the oldest building 1953, 763 buildings have been damaged. That's the first place. This is second place, probably 1980. It's this kind of buildings. So many 165 buildings. Now this is 1995, 280 buildings, etc. So you understand the point now. You can so what we have learned from this exercise, we can see and symbolize, if we have the sufficient amount of field data, the tornado path and tornado magnitude. We can also learn to predict the future path of tornado and what kind of buildings have been impacted based on the buffer. But of course buffer depends on many things such as wind speed and the magnitude, but also we can analyze using the buffer tool the number of buildings have been which were impacted, and statistically analyze different attributes which are related to these buildings.